and I can plug it in the next socket. I plug it in the next socket. I don't even have to look at the meter. When I've finished, I can read the highest number. Yeah, because I only record the highest number. So that's what the Z-Max is for. When I go to RCD tests, I've got an array of tests. I've got a half test, okay, 1 times test, 5 times test, auto, and what we call a ramp test, okay? And then on this side, I need to set this dial to something, and this is where I set it to how big the RCD is, okay? So my standard domestic RCD is 30 milliamps. 10 milliamps are used in, Donna! Oh. She knows he's in yet. Donna was looking for you, Sonny. Donna. 10 milliamps, they're used for hospitals and things. Well, I want a highly reactive RCD. Yeah, so I don't want my hospital patients getting any form of shock, because I've got people in there with bad conditions, bad hearts. If I get pacemakers, if I get a 30 milliamp shock, it ain't going to kill me. Most of you are going to get a 30 milliamp shock, it isn't going to kill you. I say most of you, I've had loads of 30 milliamp shocks, and they don't kill me. Right? Most of us, if we've got a good heart, no heart condition, we're healthy, we have a 30 milliamp shock, we're all going to live. Okay? If I've got a pacemaker, or I've got a heart condition, and I have a 30 milliamp shock, that can be enough to stop my heart. Yeah, enough to stop my heart. So we go down to 10, which limits that again. Okay, I've got 100 milliamp. Okay, I've got a 300 milliamp and a 500 milliamp. They are, you have to, all those ones. You can set various and put a custom one in as well. 100 milliamp. If I'm fed by an overhead cable, I have to have 100 milliamp RCD as the incomer, even if I've got 30 milliamps for everything else. Okay? That's because if I'm fed by overhead, I have to have an earth rod. Okay? The earth of an earth rod is not very good, the resistance I get. So to ensure that I trip, I need 100 milliamp incoming RCD. We'll trip on a full earth fault. 300 milliamps and 500 milliamps are used in specialist environments. Say, for example, I'm in a factory where I need to provide some form of RCD protection, some form of earth detection. But I've got so many big machines that naturally give an earth leakage that I can't run on a standard RCD because of the type of equipment I've got. So you probably will never see a 300 or a 500. I've got a 300 on the incomer here, and then 30 milliamps on the outlets for that reason, because I've got a lot of potential faults. So I want protection on the incomer, but for where you guys touch, I need 30. Yeah, but I have 300 on the whole thing. Okay, just to protect us all. That's various. No, it's variable. Sorry, variable. It means I can set it to a custom. Somebody somewhere out there may have an RCD designed for a specific custom design. Yeah, so it allows me to test this. You'll never ever use it because you'll never go anywhere that bizarre. Yeah, that will be in like nuclear power plants, power stations. They'll have all sorts of strange things developed especially for them. Yeah, they're building those already. So, an auto, what that does, on my test form, I have to test. You've got a half test. What I want to make sure when I leave somebody's house, I want to make sure that their RCD works, but it doesn't work when there's just a bit of a fault. Okay? Now, for example, your fridge freezer at home will have a 3 to 5 milliamp earth leakage naturally as part of its operation. Okay? Because what it is, I don't know if any of you air conditioning and refrigeration, you've got an encapsulated motor. Okay? That motor is physically inside the gas that's being pumped around your fridge. Okay, so it's actually encased. The compressor has got the motor inside. The motor is there. Now, if that, depending on the design of that, some of that gas is liquid and some is fluid. So that means my motor is sitting in liquid. Okay, it's not an ideal situation for anything. You have therefore some conductivity. So there's naturally some leakage of that electricity, and it's 3 to 5 milliamps it leaks naturally. Okay, so if I've got a 30 milliamp RCD and I have 10 fridges on it, and all 10 decide to at the same time, the RCD will trip because I've got 10 3 milliamp leaks. Okay, if I've got 3 fridge freezers at home, so I've potentially got 9 to 15 happening. Okay, but so what I do a half test. So if I've got a 30 milliamp RCD and I put it on half test, it puts a 15 milliamp fault on the circuit to make sure it doesn't trip. Okay, so as an electrician, as part of my testing, I do a half test. Okay, the other thing I have to do, we know the electricity. Some RCDs only work on the positive cycle. Okay, so don't know. I was testing over there. I think. So it's a test meter somewhere. So as it only goes on the positive cycle. So at 50 hertz, okay, I only get to the positive cycle only 50 times a second. Yeah. So a 50th of a second. So if I start the fault when it's on the negative part of the cycle, nothing happens for half a cycle. So as an electrician, I have to test it and put the fault on just as the positive starts and just as the negative starts, 180 degrees out phase. So this meter looks at the sine wave and it goes, I'll put a fault in now and see how long it takes the RCD to trip. We then have to put the fault in at 180 degrees off and see how quick it takes. And if it's an old type RCD, it takes 1 cycle longer, yeah, to trip, okay? Because under the regs, I have to ensure that that RCD is going to trip in less than 0.4 of a second, yeah? So we only get a 30 milliamp shock for 0.4 of a second, yeah? So I don't want it to be longer than that, yeah? So this will tell us if it's done. I then do a 1 times test, and I do that at 0 and 180, see how fast it is. We no longer do the 5 times test under the regulations. They've stopped us doing that in 2022 because they felt we were blowing up too many RCDs when we were testing. Okay, if you're putting too big a fault on the circuit, I still do it. And then I've got auto, and what auto does, you can see what I would have had to have done was press that, yeah, gone to test, and then I would have had to press the test button to change it, and tested it. Then I would have had to have pressed that button to change it to 180, press test again. I then would have had to have turned it to there and press test again. Press test again. Then I would have had to have left it there, press that button, press test again. Turn it round, so I've had to turn and press like crazy. Auto does all those steps automatically. I plug it in once, it goes test, 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 test. Yeah, so it's just faster for the electrician. Because if you think, what I'm normally doing when I check an RCD, I'm plugging my meter into a socket in the kitchen. I press test, I quickly walk to the understairs and wait for it to trip, reset it. If I've then got to go back to the kitchen, change the meter, go back, reset it, go back, it's a lot of aggro. Auto, I put it on auto, press test, walk back to the fuse box, stand there and it goes click and I go, it goes click and it goes click and do that 4 times, I walk back and see what the meter says. Yeah? So auto's brilliant. Ramp, that one, what it does is if you've got somebody that's saying the electricity keeps tripping randomly, you know, I wonder why. Yeah, the RCD just keeps going off. So one of the things we can do is we can set it to ramp, and that tells me how sensitive that RCD is. Okay. So what I do is I have the whole house switched on, yeah, and I do a ramp test, and it tells me how many milliamps it trips in. Then I turn the whole house off, just test the RCD itself on ramp, and see if there's a difference between the two. Yep. That tells me if there's any earth leakage outside. It also tells me how good the RCD is. You know, how it should, where it's tripping. They normally trip somewhere between 23 and 27, nowhere near 30, because they always leave themselves an element. The manufacturer wants to leave himself an element of safety.
RCD trips, what do I need to do? Again,
that will be a fault finding. That will be a fault finding thing. We can come to that later. Yeah, we won't absorb that now. Yeah, we'll concentrate on what we're doing. Yeah, because there's lots of reasons why RCD is true. So that's my meter. So what we're going to do, we're going to go back. We're going to concentrate on our resistance checking. Yeah, which is going to be continuity ohms. Okay. You'll see on the ohms reading. We haven't gone through this for these guys. The ohms reading, when it's off, it says it's 99.9 k ohms. Okay, that's the maximum this will reliably read to. When it's above 1,000 ohms, yeah, it doesn't care what it is. It doesn't know. It's just above 1,000 ohms. We don't care what it is because we're only interested in knowing. So this is why you couldn't really use this for electronics, because there's lots of things we want to know that are over 1,000 ohms. We want to be able to measure. It's no good for that. Yeah. It's designed purely for us as installation engineers. It's an auto test meter, this one, which means it's always going to be testing when it's on continuity. So when I put the probes together, it tests for me automatically. Take them off. It's telling me it's doing a 200 milliamp test there. And what it does handily for us is it puts our last test result up there. So if I couldn't see what I was doing, if I was up there on the light and I heard it go beep, so if I listen, I'll go like that, and I heard it click, and it goes beep, and I go, okay, that's good on it. And now I can look down at my meter, and the last meter reading's there. Yeah? So I haven't got to be looking at my meter all the time. The current reading's here, the last one's there. Current reading is 999, last one was 0. If I press that button, you see that little symbol's gone away in the corner, that's my 0. Yeah? Was up there. So now they're not zeroed. So if I put them together, I'm reading 0.08. That is the resistance of these two leads. 0.08.
So what's the 200?
No, it's gone back to 0, so I've taken them apart now. So 0.08 was my last reading. So I put it together, it should always be 0.08, yeah? I could leave it like that, take a measurement, and take away the 0.08, and I've got an accurate reading. But to make life easy for me, we've got a 0 function, so I can hold them together, press test, you now see that symbol comes up in the corner. That means the leads have been zeroed. So now, I put them together, and they're 0. Yeah, so it's nice and easy for me to use. So what we're going to do, we're going to use our test meter, we're going to 0 it, use our test meter, and we're going to do some real life testing. Yeah? It's probably break time now, is that half past? Yeah, should we have half an hour?
Yeah.
Go and get a bit of air because it's bloody stuffy in here. And I'll get a cup of tea because I've talked.
Thank you.
And and then we'll carry on. We'll do some testing. Yeah. But again, repetitive.